Welcome to Quick Engineering. The topic of today's video is deterministic finite automata. There are two types of finite automata: deterministic finite automata and non-deterministic finite automata. So what is deterministic finite automata? It is a abstract model which is used to process the string. Even if process the string, but it can process at a time, it can process only one symbol at a time. So what are the contents of deterministic finite automata? It contains number of states, transition and input symbol. So let us see deterministic finite automata. So in deterministic finite automata is represented by states, transition and input symbol. So this is the example. Here you can see there are three states, Q0, Q1 and Q2. Q0 is the initial state, so that's why the arrow is represented. Then Q2 is the final state, so that's why it is represented by double circle. And there are two input symbols, 0 and 1. So there is one important point in deterministic finite automata, that for one input symbol there is only one transition. For one input symbol there is only one transition. So if you look in this diagram, so Q01 is Q0, Q00 is Q1. So for 0 there is only one transition, for 1 there is only one transition. Q1 0 is Q2, Q2 0 is Q2, Q2 1 is Q0. So you will find only one transition for one input symbol. So that's why the name is deterministic. Now deterministic finite automata mathematically defined by 5 tuples. So the values are Q sigma del Q0 F. So what is capital Q? Capital Q represent the number of states, which is here Q0, Q1 and Q2. Sigma represent the input symbol, which is 0 and 1. Del is transition function. Transition function is defined by transition table. Q0 means initial state, F means set of final states. Now there can be one final state or more than one final state in deterministic finite automata. So let us see the value. Capital Q is equal to Q0, Q1, Q2. Sigma is equal to 0 and 1. Q0 is equal to Q0. F is equal to Q2. So what is F? F represent final state. Now remaining part is del. Del is nothing but transition function, which is defined by transition table. So how to draw the transition table? Transition table is drawn from the diagram. So on left hand side, write down the state name Q0, Q1, Q2. Q0 is represented by arrow, Q2 is represented by circle. The reason is it is final state, and Q0 is initial state. And then write down the input symbol 0 and 1. Now you have to fill this value by diagram. So if you look at the diagram, Q0, 0 is Q1, Q1, 1 is Q0 by looking into diagram. Then Q1 0, Q1 0 is Q2, Q1 1 is Q0, Q2 0 is Q2 and Q2 1 is Q0. So this is the transition table. Now when you can say that the string is accepted in finite automata, deterministic finite automata, when you reach to final state, then you can say that the string is accepted. So to check that verification, I use here string 100, and I will trace this string on this diagram. So you can also refer this transition table. So del Q0 comma, so how to trace it? You have to start with initial state. Q0 is the initial state, and then this is the string. So del of del Q0 comma 1. So what is Q0 comma 1? Q0 comma 1 is Q0, so that's why there is Q0. Then del Q0 comma 0. So I told you DFA process only one symbol at a time, so it will take only 0. Q0 0 is Q1. Now Q1 0, Q1 0 is Q2 and Q2 0 is Q2. So now you can say that the string is accepted by deterministic finite automata. The reason is you reach to final state and there is no more symbol remaining, hence the string is accepted. So that's it for this video. If you like the video, please subscribe, like and share. Thank you.